Hi lads, so what we'll move on today is equations involving indices. This is following on now from the video that Miss Lehan did on the fractional indices. Okay, so what we have here is 2 to the power of x is equal to 8. And in this one, 2 is what I call my base number. So that's the big number and that's my base number. So what I want on both sides is the same base number. So I have 2 to the power of x here, that's fine, that stays the same. Now, how can I rewrite 8 using 2 as a base? So onto the calculator, 2 to the power of 3, that gives me 8. So I'm going to rewrite here 2 to the power of 3. Now, when you have the same base on both sides, you can circle x equals 3. Okay, and that's your answer done. So you want the same base on both sides. The next one, I have here 4 to the power of x equals. Okay, let's rewrite 64. So we know 4 squared is 16. So we'll try 4 to the power of 3, 64. So I'll rewrite 64 as 4 to the power of 3. So I can circle x equals 3. So you have to have the same base number. It's kind of like they cancel each other out and you're just left with x is equal to 3. The next one. So I have 3 to the power of x equals. Now, how can I rewrite 81 using 3 as a power? So 3 cubed is 27, so that won't work. So it's 3 to the power of 4 is 81. So instead of 81, I'm going to write 3 to the power of 4. Same base on both sides. So I can circle x equals 4. Okay, on to the next one. 5 to the power of x is equal to 25. Well, we should know that one. 5x is the same as 5 to be squared. So 25 is 5 to be squared. X is equal to 2. Okay, but you must go through all the steps, no shortcuts. Okay, let's go down here now. So 3 is my base number here. How will I rewrite 27 using 3 as base? So it's 3 to the power of x is equal to 1 over 3 to the power of 3. Okay, but remember from yesterday, if I want to bring this above the line, what do I have to do with the power? Change the sign. So that side stays the same. So I have 3 to the power of x equals. So that becomes 3 to the power of minus 3 when it comes up. Okay, so you flip it. So you flip it and you have x equals minus 3. X equals minus 3. Okay, and the last one of these now. So I have 25 to the x is equal to 1 over 125. Well, I can see straight away anyway, 5 is going to be my base number. So you have 5 squared to the power of x equals 1 over. Now, so 5 cubed, that gives me 125. 5 cubed, okay? Now, remember our rules, a power to a power, you multiply them. So I have 5 to the power of 2x equals. What happens when I flip this? I want this up on the top line. So I have 5 to the power of minus 3. Then I check. Bases are the same. 5 is the base, 5 is the base. Circle, and solve. 2x is equal to minus 3. So x is equal to minus 3 over 2. Okay, let's go down to these ones here. Now, express in the form 2 to the power of k, where k is an element of n. That just means that k there is a normal number. All right. So, 32. How can I rewrite that with 2 as a base? So that's going to be 2 to the power of 5. Okay, you might need to check those on your calculator. All right, 2 to the power of 5. So we have 2 to the power of 5, and that gives me my 32. So you're just rewriting it. And we know that the square root is the same as writing to the power of a half. So you have your half here. Now, remember from your rules of your logs, when you're multiplying, add the powers. So it's 2 to the power of, so you have 5 plus a half, and it's 11 over 2, or 5.5, whichever you prefer. Okay, the next one. Now, the first thing I'm going to do is, instead of a square root, I can write that to the power of a half. And how do I write that with 2 as a base? So 2 is a base for all of these, so it's 2 to the power of 3. Now remember, when you're dividing, what's my rule? Subtract the powers. So it's 2 to the power of, so it's going to be a half, take away 3, which is minus 5 over 2. minus 5 over 2. But I don't really like having negative powers. So remember, that's over 1. So if I flip it, I'll get 1 over 2 to the power of 5 over 2. Okay, because I don't like being left with a negative power, so I'll flip it. The next one. Okay, so 16. Rewrite that with 2 as a base. So that is going to be 2 to the power of 4 over 2 to the power of, remember the square root is just a half. What are my rules when I'm dividing? Subtract the power. So 4 take away a half is 3.5. So your final answer, 4 to the power of 7 over 2. I usually leave it as a top heavy fraction. Okay? The next one. So solve for x. So we have 1 over 5 to the power of x is equal to 125. Again, you're always looking at your base number. What's my base number going to be here? It's going to be 5. So bring that up to the top line or flip it. So you have 5 to the minus x equals 125 can be written as 5 to the power of 3. Same base on both sides. Circle, circle, minus x equals 3, so x equals minus 3. Okay, over to the next one. Now, how would I break that up? That's 2 to the power of x multiplied by 2 to the power of 1. Because remember, if you're multiplying these two, add the powers. So that would be x plus 1. Okay, so it's like you're going backwards now. Equals 2, sorry, and no, we actually don't need to do that. That's fine. So leave that as it is, sorry, and rewrite 16 as 2 to the power of 4, and then circle, circle. So I have x plus 1 equals 4, x equals 4 minus 1, x is equal to 3. Okay, so we don't actually need to break that up. It's perfect as it is. So same bases on both sides. Base to the power of something. Circle, circle, and put them equal down here. Okay, one more page there to go through. Okay, so the problem I think with these lads is that they don't look great when you look at them. They look a small bit, they look a bit awkward, right, with the square roots and the powers and all that. But just go down through them slowly, get the same bases, and when you have the same bases on both sides, put your powers equal. Okay, so just from looking at these numbers, you'll get used to them after a while. Your base is going to be the number 3, okay? So how do we rewrite 9? So it's going to be 3 squared. Now, that's all to the power of 3 minus x, because you're copying what you have up there, equals. Now, that would be 27. So how do I rewrite 27? I'll actually just do 27 to the power of a half first, because I'll rewrite it afterwards. And then I have 81 is 3 to the power of 4. Okay, now when you have a power to a power, you multiply. So multiply, it's going to be that by that and that by that. Okay, so you have 3 to the 6 minus 2x equals. So how do I rewrite 27? That would be 3 to the power of 3, all to the power of a half, all over 3 to the power of 4. Okay, so we'll go up here now. All we've done there is change 9 becomes 3 squared, power to a power, then you multiply. Whenever you see a square root just by itself, you can change that to the power of a half. All right. So what do we have now? On the left hand side, I have 3 to the power of 6 minus 2x. And on the right hand side, remember, power to a power, you multiply. So it's 3 multiplied by a half, which gives me 3 over 2. So it's x to the 3 to the power of 3 over 2. Over, so that's what that one became, 3 over 3 to the power of 4. So this side stays the same. Now, when we have division, what's my rule? You do 3 over 2 minus 4, and you're going to get minus 5 over 2. So 3 to the power of minus 5 over 2. Okay, so that's kind of it's tricky enough one. Same base on both sides. Circle, circle, and I put those two equal. 6 minus 2x is equal to minus 5 over 2. So minus 2x equals minus 5 over 2 minus 6, because we're bringing it over. Minus 2x equals, so we minus 5 over 2 minus 6 is minus 8.5. So you have 2x is equal to 8.5. So x equals divided by 4¼ okay, 4¼ that was kind of a long enough one, wasn't it? Okay, so that is all of that together. Okay, next one, 2 to the power of x plus 4 equals x all over the square root of 2. Okay, so pause, think. What am I going to use as my base here? So I'm going to use 2 as my base. Okay, so the left hand side is fine. I just need to sort out the right hand side. So the left hand side, keep that the same. 2 to the power of x plus 4 equals. How can you rewrite 8 using 2 as a base? It's 2 to the power of 3 over. Remember, if you have a square root, same as a power of half, 2 to the power of a half. Okay, so you've 2 to the power of x plus 4 equals. Now, what do we say when we're dividing? Subtract the powers. So we have 2 to the power of, we have 3 minus a half, and that leaves me with 5/2. So 2 to the power of 5/2. Then I've got the same base on both sides. Circle, circle, and I put them equal. So I have x plus 4 equals 5/2. X equals 5/2 minus 4. X equals, so you have 5/2 minus 4, and you get minus 1.5, or minus 3/2. Okay, last one for today then, lads. So the next one is right in the form 5 to the power of k, where k is an element of q. That is a rational number, which means it'll be just a fraction. Okay, it's a rational number. So now I'm going to rewrite 125 using 5 as a base. So that is going to be 5 to the power of 3 over, if I have a square root, how do I rewrite it? 5 to the power of a half. Division, what's my rule? Subtract the powers. So you have 3, take away a half, which is 2.5, which gets me 5 to the power of, so 5/2. And the last one then is going to be 1 over. Okay, using 5 as a base here. So 25 is going to be 5 squared, and that's multiplied by, if I have a square root, just change it to the power of a half. And that's 1 over. Now remember, when you're multiplying, add the powers. So add the powers, so it's 2 plus a half, and you get your 2.5, or 5/2. So it's 5 to the 5/2. Now I want to bring that up to the top line, because I wanted 5 to the power of something, so you're going to flip it. So it becomes 5. Remember, when it comes up, the sign of the power changes, minus 5/2. Okay, now that was quite a long video, lads, because there's a good bit there. So those questions keep you going for 2 days. And drop me an email if you're stuck on them. Go back over that video again if you need to, and I'll put up pictures of those notes as well. Okay, thanks, lads.